Bad data means your machine learning tools are useless. There's a saying that I'm sure you're all familiar with. Shite in, shite out. And what this saying quite articulately and succinctly expresses is that an input of poor quality will lead to an output of equally poor quality, resulting in flawed concepts and negatively impacting decision-making, reputation, and revenue. Harvard Business Review estimates that poor quality data costs US businesses over $3 trillion annually. So let's imagine what the impact of poor quality data is going to be on machine learning. Unlike traditional software, machine learning is made up of two distinct parts: the code and the data. And what this should tell us is the data is incredibly important. The data demands of machine learning are steep and high. And the flaws in that data, whether they be from badly calibrated sensors or corrupted databases or even simple human error, will be reflected in machine learning tools not once, but twice. Firstly, when you're training the models on the historical data, and secondly, when you're feeding in new data to get predictions. At best, bad data will lead to a lack of insight and waste of money. And at worst, they will create totally misleading models and false trends. Some people would argue that the law of large numbers will iron out imperfections and that bad data can be managed this way. People do keep talking about big data, how we need more data. And Peter Norvig famously said, "We don't have better algorithms, we just have more data." And all of this has led to the idea that data quantity is the key. Interestingly, a team at MIT recently examined the 10 most used data sets in the world and found that approximately 3.5% of the data in these data sets was misidentified, inaccurate. Babies labeled as nipples, lionesses labeled as monkeys, and birds labeled as stoves, just being some of the examples. They found that when the models that had been trained on the mislabeled data set were trained on the same but newly clean data sets, they performed noticeably worse. What the MIT team concluded is that this relatively small error has caused errors in thousands of peer-reviewed articles and biases that have found their way into commercially available systems. Now, I don't think I could talk about data quality without mentioning Andrew Ng. And one of the ideas that he talks about is that when a model is performing badly, most people instinctively move to try and improve the code. And yeah, I've got to hold my hands up here. I completely do this. When a model's not performing badly, I'll look at a different choice of algorithm, the tuning, hyperparameters. But actually, Ng holds up an example of a model that's used to detect deficient inspection in steel. And they couldn't move the performance by being code focused. But the accuracy jumped 17% by going back and improving the data quality. But that makes sense. I mean, these exciting artificial machine learning algorithms and models, they only make up 20% of the workload. Data scientists spend 80% of their time processing and cleaning data. It might be tedious, but going forward, I'll definitely be looking at data quality first.